And welcome back to another data structures video. So in this video we're going to go over a brief introduction to a list. So what exactly is a list? Well, a list is nothing more than just a collection of individual items of the same type. So exactly how is this different from an array? Well, if you remember from last time, an array had a static length, meaning that once we create the array's length is set in stone. A list is a collection that can keep growing no matter what. There's basically going to be no set limitation for how many items we can add to our list. So here are a couple of examples of lists of items that can either be refrigerated or kept at room temperature here. And yeah, they're pretty cool lists as far as things go. Actually, when I looked at this list, I learned something new. I always thought that you could keep apples and grapes at room temperature. Eggplant, I don't see why that needs to be refrigerated, but once again, I'm not much of a fruit grower or a farmer myself. So, all right, so let's talk about implementations of lists. So there are two ways we can actually implement lists. The first implementation we've already kind of gone over before, which was through an array, because an array is a collection of items. But how do we make an array turn into a list using the array? This is known as an array list. Well, the way we're going to do that is by using, quote-unquote, a dynamic array. So the idea of the dynamic array is we first start off with our original size or our default capacity of our array, and in this case, this array happens to have a capacity of 2. Once we fill up all the contents of the array, basically meaning that the number of items that we have has reached the capacity, what we're going to do is we're going to double the size of the array and then copy over the elements here. So as you guys can see, we have 2 and 7, and when we try to add the 1, we double the size of our array and then add that 1. Once we get over here, we have 2, 7, 1, and 3. We filled up the array, but we don't double the size up until we try to add a new value to our array. When we add a new value to our array, we double the size and copy over the data values to this new doubly sized array. So, another implementation is by keeping a collection of individual nodes. So in this case, a node is a data structure that contains some sort of data, and then it contains a reference to the next element that it is pointing to. So in this case, we start off with a 10, and then what we do is we add a new node with the data element of 20, and then we say that the 20 is now pointing to the 10 here, which is how we get to this line. And then we create a new node with the value of 30. We say that this 30 is its next value is going to be pointing to this 20, which is pointing to the 10, which is how we get this. And then we add a 40 to the very front of our chain of nodes. This is also known as a linked list here, because we've linked a whole bunch of nodes here in a list sort of fashion. Okay, so now let's talk about the applications of lists in the real world. I'm not sure if you guys can see this over here. This is a list of schools, Harvard, Yale, Brown University, Princeton University, so forth and so on. So we have a list of individual college names. And then corresponding to the college names here, we also have a list of average SAT scores here on the math side over here and the critical reading side. And then just kind of a summation of the totals between the critical reading and the mathematics. So these lists are very helpful in the sense that they do give us a bit of information of what it might be like to go into a school like one of these, what the expected range of values is for the SAT. But one thing to note is that these lists of schools here and the SAT scores in general are not ordered in any sort of fashion. They're not ordered in terms of which letter or which school starts with the first letter of the alphabet. It's not organized by SAT total scores and whatnot. So basically, this just tells us that lists don't really care about the order. And it's entirely possible that we could have multiple duplicates inside of our list in general. And you guys probably see right here for the University of Pennsylvania and I think this is, I want to say Cal Poly Institute of Technology, but I can't really see that. But anyways, it looks like, from what I can see, it looks like the SAT critical reading scores for the start of both the ranges is both 650 for each of these. But remember, the SAT critical reading column represents a list of SAT scores in the critical reading section of the SAT. And there are start duplicates here, so duplicates are allowed in lists. And then another application of lists is in medical records, for example. Over here, we have a bunch of different terminology over here. I don't know any of it, to be honest. I'm just assuming that it's medicinal related because I see genetics. I also see parasites over here and pathogen. Bunch of medical terminology that I'm very unfamiliar with. So, idea is lists can be used to keep track of numerous amounts of things. As we saw in the second slide here, they kept track of individual food items that could be stored at various temperatures. They can keep track of individual numbers. They can keep track of SAT scores and rankings of individual diseases or whatever these are. Basically, lists are there to keep track of information. So I hope you guys found this video somewhat helpful, and we'll see you guys next time.